Okay, in today's video what we're going to be talking about is how to set up an analog card. Basically this would be a 1756 IF8 analog card. Most analog cards are just about the same, so this would be helpful on many different versions. Basically I'm just going to talk about some of the basic common features and hopefully spread some little bit of knowledge to those of you that want to know. This actual analog card is a non-isolated voltage or current analog input. First thing we're going to talk about is the RPIs. So the first connection or the first tab you have is your RPIs. Of course, that is your requested pack intervals. So that means how fast you want the processor to receive data from your card itself. So meaning, at this point it's going to wait 100 milliseconds before it processes any input from this card. You have your inhibit tab. You inhibit it in case you don't want to use it. So if you inhibit it in your chassis, it's not usable at this point in time. So that's something you can do if you're troubleshooting or something of that nature. You can always check if there's a major fault that can fault the controller. I generally don't do that. The module info just shows you the info itself of the module. The next thing is where we're going to get into actual configuration. So in this card itself, and most cards have different channel setups. So keep in mind that when you set one up, you're not setting the whole card up. You're setting just one. So this, have channel. This is a 4-channel card. I have channel 0, 1, 2, and 3. Okay, so channel 0 right now I have set up for analog 0 milliamps to 20 milliamps. You can put an offset in there. You can put a digital filter. You can also change your input range if you wanted to. This is where you do it. If you have a 0 to 10, if you have a 0 to 5, negative 10 to 10, 0 to 5, and 0 to 10. In our case, we put this one at 0 milliamp to 20 milliamps. So you can put your high so basically your scaling, your high limit or your high signal would be exactly what it is supposed to be up here. So you have to know you have to be within your input range. So if I chose to go out of my input range, it would not accept it. It would say channel 0 is out of range. So if I'm in range, then it will actually accept it. So the high and low signal, this should match just about what you have over here, or at least be within the ranges. You can set it. I would say you can set it lower or high, or you don't have to set it exactly the high and low range. You can set it within tolerance, right? What I mean by that is, in between 0 and 20. I can put this at 19, or I can put this at 1, or even 4 to 20, right? So I can say this is going to be 4 milliamps, and you can still accept it at that point because it's within the 0 to 20. So in that case, I can say right here that my engineering units in this case would be whatever I choose to use. In this case, my 4, which is my low milliamps, right? I would say this is 0, or I could say this is, whatever. I can say that's, however you want to scale it. In this case, we would keep it at 0, because if you did have a 4 to 20 milliamp signal, then 4 would be 0, and anything below 4 would be negative. So in your high instance, which would be 20 milliamps, your 20 milliamps, you could scale whatever you want. This could be whatever range input you choose it to be. In this case, I just put 20, but just know you can put it at whatever you want, like 100. You can, so 0 to 100, right? So if we did percentages or whatever, something of that nature, then it would be like that. So that pretty much talks about a rough setup of a 4 to 20. So the next tab, and that would be on channel 0 again. So if I did the same thing, if I had my whole card set up as 4 to 20, then I would need to do each one of these at 4 to 20. In the next tab, we can talk about the 0 to 10 or the negative 10 to 10. This is basically the same. You want your high signal and your low signal to be there. You can obviously change that to whatever you want, based upon whatever your scaling is. Engineering scaling is done the same way, whatever you want to your units to be scaled at, to be used inside your program. That's basically what that's there for. In the next instance, you could go to 0 to 5. You can go to 0 volts to 10 volts. If we were to have, like, generally speaking, you're going to have your card set up all the same way. You're not going to have one set up to 0 to 20 milliamps, the next one set up to negative 10 to 10. You're just going to have it all set up the same. So if we do, what we'll do real quick is I'll just go ahead and set all these up to match. So we'll say 4 milliamps, and then we put this as at 100, and this is 0. We'll accept. Channel 2 is messed up right now. No big deal. We'll come in and change that. Come in and put this just like we had the rest of them, and do one more, and then this would be 20, this would be 100, this would be 4 milliamps, and this would be 0, and change the of course the input. So now that we've changed it, but of course maybe, oh yeah, I have it set wrong. Okay, so now we have our whole card set up to 4 to 20 milliamps, and that's again to operate off of 4 to 20 milliamps. The reason you don't want to exceed that is because your input range is 0 to 20 milliamps. So again, so in here you can put your alarms. So now you have an alarm space that you can come in here and have actually a high and a low alarm. And you can have a high, which is basically saying, okay, so if I wanted 20 milliamps to be my high, then I could say my high limit would be 9 milliamps. In my complete setup, obviously I can go from 0 to 20 milliamps. Even though I'm set up from 4 to 20, I have my card set up to 0 to 20. So then I put my absolute low limit at 0, and then my low limit at 4. So 4 milliamps, and then high would be 20. So that kind of gets, and you can put you can change the way things work and stuff of that nature. You can disable alarms if you don't want to use alarming. If you're choosing to use alarms, you can use the latch process. You can do, I mean, there's a couple different features you can do in here as far as that goes, but just make sure you keep the alarming, if you're choosing to use it, keep it all the same, based upon your application. Again, this is all application based, right? So however you choose to end up using it, and however your application is set up, that's basically what you want to use it for. So in this case, we're 4 to 20, so I want to make sure that I do come in here and put and you'll see over here your limits to change, right? So as far as each one of these, now I have them set, and I'll just apply that. Now you also have a calibration too. So you come in here and you can calibrate all these as far as that goes. Now this comes calibrated from the factory, which in this case, this module was last calibrated successfully on 8/12 of 2004. So that was probably when the factory did it. You can actually do that and actually throw in offsets and calibration gains and stuff of that nature. So if you started a calibration, then you would basically want to come in and, actually, do you want to calibrate this one? So, what's the calibration ranges as far as that goes? As far as, and this is down here, you have calibrate the channel in groups, or you can calibrate the channel one at a time. So as far as that goes, you can just do one at a time. You can do groups. Not really going to so much get into that because that can go, draw out the video quite a bit. Just wanted to kind of show you that you can actually do that. The last tab is actually just talking about faults and clearing faults, refreshing data, stuff of that nature. So again, make sure I always keep my stuff at compatible keying. Then I come down and set my card up however I want to use, whether it be 0 to 10, 0 to 5, or 4 to 20. I normally don't do a negative 10 to 10. I'm sure there's applications out there that do, so I'm just wanting to say that whatever you choose to use as far as that goes, this is basically the things, two major things that you want to look at is configuration and also alarming. And you can also disable alarming and not even use it, like just on one axis. Say you had trouble with on one channel, you can actually disable that alarm. So when you do that, you're not disabling alarm on all of them, even though it says all alarms. It's all alarms on that one channel. So you see I still have an alarm over here. So I just wanted to kind of highlight that too. So just to because a lot of people think that once you have that check that it's actually affecting all channels. It's only affecting the channel you currently have highlighted. Okay, so that's pretty much a rough overview of the analog input card, and this is again the 1756 IF8, so 4-channel input card. Okay, so hopefully that was helpful, and if you haven't subscribed, please subscribe so you can get all the notifications and updates. For those who have subscribed, thank you, and look forward to hearing your comments and stuff about videos you'd like to see in the future. All right, thank you.